actually look at some review of everything we talked about in this unit. So this is our last unit on quadratics. So going to try to pull everything together so we get a bigger picture of what we've been actually doing. Your textbook is kind of all over the place, so hopefully this will help. Okay, one of the things that we've done in this unit is a thing called completing the square, and I will do an example of that a little bit later on. Okay, now why do we even bother completing the square? Well, there's a few reasons. One, to find the vertex. So if I'm just after a pure question of how to graph something, it's easier for me to complete the square and find the vertex that way. Another reason why we complete the square is it gives me the maximum or minimum value, depending whether parabola turns up or down, and when it reaches this value. Okay, and so it's really important for that aspect of it when we look at word questions, and we'll talk about it in a moment. Okay, so we complete the square to find the vertex and or to find a maximum or minimum value and when it occurs, that value. The other thing we talked about was the quadratic formula. Now the quadratic formula, why do we do it? We do it to find the zeros. Okay, so mainly that's the reason we do it, just to find the zeros. Now, the reason we have to use the quadratic formula is because if you know, I say factoring, why? Well, to find the zeros. And there's some other reasons why we factor too, and we'll talk about that in a moment. But so completing the square, quadratic formula, factoring. So when it comes to word questions, how does all of this fit together? Well, word questions. To complete the square, if the question says maximum or minimum value, so as soon as you see that word, when's the maximum or what is the maximum? What is the minimum? When does it happen? All of that tells me that I need to complete the square to solve it. Now, how do I know whether I should be using the quadratic formula? Well, for the quadratic formula, word question will say when the height equals 0 or when it reaches 0. Okay, so I'm more concerned of when, especially if we're talking about, and most of the times we are talking about it, when we're talking about some kind of projectile motion, we're talking about when does it get to this location here. That is what we're interested in because that's the 0. Okay, so that's when I would use the quadratic formula, or even I could use factoring too to find those zeros. Okay, now continuing with the factoring, another reason I can factor, the other piece of information it'll give me is halfway between the zeros is the axis of symmetry. So in other words, if I can find these two 0 points, halfway through will give me the x coordinate of the vertex, which means I wouldn't have to complete the square. Okay, now to find, I wouldn't have to complete the square to find out when, but I still would have to do something extra to find the actual maximum value. The other thing that we did in this unit was the discriminant. And why did they make you to do the discriminant? It was to find the number of zeros. Okay, so if you look at this, we're interested in zeros, zeros, zeros. So we're interested in when it hits the x-axis. Okay, the reason being is because in a lot of cases, that's when we're talking about word questions. We're interested in those. Okay, so what happens if my discriminant equals a negative number? I know I have no zeros, which means I don't need to worry about factoring, and the quadratic formula won't work either. Okay, so it has some benefits to know if there are no zeros. So now let's look a closer look at special features of quadratics. Okay, so what I've done is I made quite a few different little scenarios here. You notice they're all a little bit different. And the reason is that we can talk about them. Okay, the first thing is the vertex. Now I'm going to switch to purple so I match the wording. And I'll make it a little bit bigger. So the vertex is the highest point if a parabola turns down, or it's the lowest point if the parabola turns up. Now, the reason I'm interested in the vertex, again, or the reason how I can get it is I can complete the square. Okay, completing the square will help me find the vertex. Okay, the other thing I'm interested in is, as I said, the x-intercepts. In other words, the zeros. So I'm interested in that. So I'm interested in these locations on this parabola. Now, the reason I'm interested in them, we talked about that because it happens when we're talking about word questions, but also the way I get them is either by factoring or the quadratic formula. The next thing that I'm concerned about is the axis of symmetry. Now, the axis of symmetry, I can get it if I know the vertex, but if I don't know the vertex, what I can actually do is I can actually take these zeros and find it. And the way we find it, and some of you maybe already remember, is it is halfway between the zeros for the axis. Okay, so that's how we get the axis of symmetry. And then if I wanted to, I could also then substitute that number into the equation to find the y coordinate. So I could actually use this zeros in order to find my vertex. So there's a few different ways. So in order to do that, as I said, we would have to find halfway. So half and another half, or half, another half, whether it turns up or down. And that x value then becomes our axis of symmetry. Okay, so halfway down. Okay, now if we know the x value, okay, so we're interested in that x value, we can use it again then to find the y value for our vertex. So it works that way as well. Okay, the other thing that we were interested in was the y-intercept. Now the y-intercept, in some cases you're thinking, well, why do you need it? Well, we need it if obviously if we want to graph, it makes it a little bit easier. But another reason we need it for, sorry, I should have switched to red and pen. The reason I'm interested in it for word questions, that is the starting point. Okay, so how high were you before you threw the ball? Well, that's the y-intercept. Okay, so that tells us what it would be at the very beginning. So in order to find the y-intercept, what I do is I let x equal 0. Okay, so that gives us kind of an overview of how all of those things work together to form a better picture of what our parabola is doing. Okay, so now what we're going to do is I'm going to go to the next page and we're going to do a few examples, one of completing the square and one of using the quadratic formula. Okay, just for a review before we do review questions.